Okay, now I'm recording. Now I'm going to share browser. And so I'm going to go over the Google Slides first. And so this is just a bit of history and some examples of animation. So I'm going to go into the slideshow for this. So again, I'm just going to go through these slides and show some examples and stuff. If you do have any questions or comments, I'll try to listen for those and just interrupt me whenever. I don't know what this looks like on you guys' screen, but it's kind of glitchy on my screen. Let's see if I can fix that. Actually, I can't edit these slides because they're created by Professor Pincus, so I can't really change that at all. So let's just stick with this for now, and then I'll go back into the.
We can see them perfectly. They're not glitchy.
Oh, really? Okay. Maybe I guess it's just maybe since I'm streaming and recording, having a hard. So anyway, I'm gonna go. I'll go back into the slideshow in the next. And so okay, so here we see an animated GIF and just a basic definition of animation. And so animation is a rapid succession of still sequential images shown at a steady rate to create the illusion of movement. And so this is also kind of true of video and film in general, but with animation, since we're a lot of the time we're drawing all the frames one by one, we're creating a sequence of images, and then when we render it or play it back, if we play it back fast enough, like a flip book, we just see what looks like motion to us, even though it really is just a sequence of changing images. And so before we had film and digital approaches to animation, there was actually a lot of physical ways that animation was done. So there's a few examples here from history of different ways that we use physical mechanisms to create animations using drawings or images or photographs or different things. So we'll look at some examples of this. Is a very early example of a phonetic. I don't actually know how to pronounce this. Phenakistic. And this actually used like a turntable technology, similar to like if you've ever seen a record player. And essentially, what it did is it just had a series of images that created like a loop, and it would be printed out and then spun around. And they used the little slots in the material to create to kind of block the images, so you would only see one image at a time. But when it's spinning around, it starts to create the animation. And so this is very early. This is from 1832. So this is just using a motor spinning, and it spins this disc, and it creates this flipbook effect because each image is replacing the previous one, and so it looks like motion. Um, this is a zoetrope, and this is a similar idea, except it's created inside of a cylinder. And this was created at the same time, another experiment with a mechanical style of animation. You can see in the example here, there is a drawing with another series of images. And this time they have slits in the outside of this cylinder. And so you can look in through the slits, and it creates this animation example. I thought there were videos of this, but I guess there's not. We can actually, let's go over to YouTube for a second, because I think we can find, I don't know about the first one we saw, but we can definitely find a video of a zoetrope. People still make these for fun these days, but we can probably see an old. Okay, so probably getting.
PayPal helps you sell online, in-store, and on the go, so you can reach customers where they are.
Right, we have the zoetrope and some horse riding this time. So this is the cartoon inside. the Zoetrop and optical animation toy, Victorian toy. Particularly nice looking one, this one. It would look just nice sitting on the side. So let's take it for a spin.
You can see if you get the right alignment and
it looks like
the
horse
images
walking
replace
off.
themselves fast enough, it starts to look like
Now I've
motion.
spun this anti-clockwise, so I wonder what it would look like if we spun it clockwise. So, because you can see that's what it looks like in between the slits.
So a flipbook is something that you guys have probably seen at some point, where it's a similar idea, where you have a bunch of images that are put together in a book, and then you can flip through, and that creates the same sort of illusion. And all of these like physical, getting more glitchy slides. So hopefully you guys, that's just on my computer, but all of these different approaches are relying on some basic physics about the way that we see. So, when we look at the world, we can only sort of see a certain amount of data. And so if we see something that looks like motion, our brain is just going to kind of put together the in-between images. And so this is referred to as the illusion of movement or the illusion of motion or other terms. So another example using photography, and this is a famous sort of experiment, but that was done by this sort of technologist and inventor, Edward Muybridge, who created a lot of the other examples that we just saw. He set up an array of cameras, so he evenly spaced cameras over the course of like a track, and then he timed it to take photos as a horse was running. And part of what this did is it demonstrated that there's a point at which the horse is not touching the ground at all. You can see there's like one frame where all of the horse hooves are off the ground. So that kind of revealed something about the world that hadn't been able to be perceived before. But this was also an innovation in terms of being able to create a certain type of film instead of just shooting, every frame of people walking around and doing stuff. By editing these different images together, you could create motion, and this is sort of the beginning of the concept of animation. So we can look at a few examples of early film animation. There's a whole bunch of different examples here. We'll just look at little excerpts. And you can see different early techniques that were created to create this sort of illusion of motion or this illusion of reality with these cartoons.
From the Library of Congress in Washington, D.C.
So you can see that's like a pretty crude example of using film editing to create these different effects. It's not really animation that we're used to, but we can see the beginnings of this idea of animation by basically using editing. We see, the actor drawing, and then they use film editing to cut to new parts of the drawing that weren't there before. This sort of illusion. Here's another early example using chalkboard.
From the Library of Congress in Washington, D.C.
Again, you can see some of the kind of like rudimentary techniques that are being used to create these sort of different illusions. One of the things I think is kind of interesting is early, when these were being made, access to things like a camera, film camera, and buying film and all this stuff made it very difficult for anybody, for a regular person to be able to make this kind of stuff. Now, obviously, we have phones, and I think we see on in a lot of these similar techniques, like VFX techniques, where you shoot one video and then you replace it with another video to create a sort of magic trick. It's popular on platforms like TikTok, where regular people now have access to this technology, similar types of edits. So let's look at a couple more of these. This is like a longer film that involves some animated scenes. I think I'm going to try to skip ahead to the end of this one a little bit.
Oh, I watched this in MES class.
Oh, really? Yeah, that makes sense. There's probably some overlap. But I want to go. This is about like these scientists creating a spaceship and going. I want to just like skip ahead to the part because it's kind of funny. But it's obviously too. Okay, here we go. So it's this kind of cool combination of animated effects and then live action performance against this like backdrop embedded with the animation. Obviously no sound in these early films, so the plots have to be very simple, so they can express things just with like very simple gesture, visual effect. So let's look at a couple more. Another chalkboard animation.
This place is magical.
Again, these look pretty rudimentary to us, but it's important to keep in mind the context where a lot of these shorts would be shown before like newsreels or films or other things like that that would be showing in a movie theater. And most of the people who were watching them at the time, you couldn't watch stuff on your phone. They had no idea how these things were made. So a lot of this stuff really seemed magic to be in this type of animation. Couple more. These ones are a bit longer, I think, so we'll just look at.
From the Library of Congress in Washington, D.C.
Oh, this one is. So one thing that you'll notice in this one is that they're repeating a lot of the same frames. So this one is a little bit different from the previous examples that we've seen, and this is all hand drawn. There's no real life elements being used, and so there's a lot more work that goes into this because they have to draw all the drawings. And so one of the ways that they can create a longer animation is by repeating the frame. So you see a lot of back and forth movement of the same frames. You see a lot of repetition of the same events. So we can see that creating an animation like this is a very time-consuming and labor-intensive process. And this is still the case today. If you watch a lot of, anime or animated television programs or movies, a lot of even big budget, big studio animations will have things like this, where you see a background that just is one frame, and then there's something animated on top of it, or you'll see a character who is like one drawing, but their mouth is changing with different drawings. So in animation, we have to use a lot of techniques to create the content without having to spend hours and hours and hours drawing every single frame, unless you're like, Disney or some massive studio hire a million. So this is quite a long one. We won't watch the whole thing, but this is all hand drawn. And it comes from a comic strip, so you can see a lot of the visual technique. Comics. Okay, so that one's kind of long, so we will continue. So another thing that we'll look at next week are ways we'll talk about them now, and I'll give an example of this with After Effects next week, but 12 principles of animation. And there's a good blog here that kind of shows examples. And these principles basically are things that we can take from the way that the physical world works, and we can, recreate them and even exaggerate them or emphasize them to create a feeling of naturalness or physical reality in our animation. So they identified 12 different kind of physical principles that can be used in animation. So squash and stretch. This is squash and stretch. This is the idea that when things are in motion, when they're going fast, they kind of stretch out, and then if they slow down or run into something, then they get squashed. Anticipation is using, subtle physical cues to kind of set up the next movement. So we see this box is kind of shaking left and right, and then it'll a little flip. I'll open these in tabs. So there we go. So staging, you see that little reaction that's happening. That's just kind of setting up, an emotional or communicative aspect of what's going on in the scene. So here we see different types of physics being added, pose to pose versus straight ahead. You can see in straight ahead, there's more frames that are added to create more movement between the poses. Maybe video. No, these are all separate. Wish there was a video that had them. So slow in and slow out. This is another technique we'll look at how to do with After Effects next week. This is basically just the idea that, when we're moving, we don't tend to move one consistent speed. We tend to slow and speed up and then slow down again as we reach the end of a motion. This shows arcs. Arcs are essentially just ways of calculating if we go up and down, we're going to move where, we probably won't go straight up and straight down. And if we move across, there's going to be some arc. Follow through and overlapping. This kind of just shows a way of emphasizing a particular type of movement. So if we're moving across the stage, there's going to be a little bit of follow through. So we're not going to be able to stop, right at a specific point. We're probably going to go over a little bit and then correct. Okay, let's see if we can load a few more of these up. Secondary action, this is pretty straightforward. It's basically just having two animations that are occurring at the same time, kind of reinforce each other. So we're adding visual components that complement each other. One box is going up in the air while the other box rotates around. Appeal is just kind of like the general idea of emphasizing motion in a appealing way. So when we're doing animation, sometimes we don't want things to be exactly realistic. Sometimes we want to add a little bit of embellishment or something like that to make the viewer connect more with them. So here we see a couple different examples of timing. On the top, we see a bit more linear timing, which is not as exciting. On the bottom, we see a little bit more emphasis placed at the beginning and the end to create a little bit more of a natural. Then we have exaggeration. This is kind of similar to some of the themes that we've been already looking at, is just emphasizing the movement. So animation doesn't have to be real. And the more we emphasize things, the more we exaggerate things, the more people see what we're trying to communicate. Of course, with animation, in this case, we're communicating without words. We want to make the visual very clear. Solid drawing, so you can see the perspective lines drawn on top of the drawing here. This just gives us a sense of the solidity or the physicality of a drawing, and that helps to create this illusion of movement that we're going for, but maybe exaggerating or embellishing on natural laws and physical. So those are the 12 principles of animation. We'll look at different ways to implement that with After Effects when we do a bit more of an advanced demo. So a couple different types of animation that we have now, in the modern world. We have 2D animation, we have 3D animation, and then we have motion animation. You guys are probably familiar with all of these, but let's take a look at some excerpts of examples. So here we have a 2D. I'm going to skip ahead a little bit. This is known as cell animation. So it has a similar quality as one of the earlier, let me turn this off. One of the earlier animations we watched, where there's usually a solid background that doesn't change. And then transparent cell sheets are drawn on to create the other frame. So that was kind of the main dominant type of animation for a very long time for cartoons and Disney movies and TV shows and things. Now a lot of animation uses 3D techniques. 3D techniques tend to be computer generated using different 3D software to create 3D geometry. Volume off on that one. So again, using computer technology to generate 3D geometry, 3D animation, 3D effects, things like lighting and materials are important in 3D animation that we don't typically work with in 2D animation. And so we can see there's a lot more parameters that go into creating a 3D animation, but a lot of the principles stay the same. You can see a lot of the same physical principles that we just talked about being used in this 3D animation. And then stop motion animation is using real life objects and film or a camera to create the illusion by moving the objects around. So let's skip ahead a little bit. don't want me to skip it. So in this example, everything is created from real world physical materials. Sorry, the playback on this. My computer is really struggling right now. That's okay. Okay, it really doesn't want to play this, so we're going to skip this, but you've probably seen some stop motion before. It can be really fun. There's a lot of really cool examples of stop motion films and Um, so as I kind of mentioned, with 2D animation, we tend to use what's called cell drawing technique, where frames are drawn, by hand, frame by frame. And so this is extremely, labor intensive. You need a lot of animators to do this. These days, obviously, it's a little bit easier to use digital technology, and so a lot of times we can fill in the frame, the main elements of an animation, and not have to draw every frame from scratch. But it's still very labor intensive, costly. 3D animation is a little bit different. There's still a lot of similarities. There's still a lot of work that goes into like character poses, designing the lighting, designing this. So there's still a lot of work that goes into that. But most of the actual frame-to-frame animation is done by the computer. Here we see a stop motion set. We can see the camera and the designers basically moving stuff around for each individual frame. And there's software that kind of like helps you do this now, where it will notice if you've moved something, or you can set a timer and it have to do. But this is also very labor. So different places where we use animation, we have feature films, cartoons on TV. A lot of animation is used in advertising for commercials. We use animation in infographics to add embellishment to data. And then of course we have animated GIFs now that are popular for memes and social networks and stuff like that. So a few terms that we will learn in the next series of demos. The frame rate is the number of frames per second in an animation, and the standard for this is like 24. We can do some examples of this, but when you go below 24, you can start to see the space in between frames, so you kind of lose that illusion of motion. If you go above 24, then you get more smooth. Keyframes are what we added on Tuesday. So we save a moment in the animation and we can keyframe a property like the opacity or the position of an object. And then we can use the computer to fill in the in-between. Cleaning is what we're doing when we put two keyframes and have the computer kind of calculate the in-between for us. The aspect ratio is the dimensions of our composition. So we looked at that a little bit when we set up our first composition with our standard HD video. And then we talked a little bit about the pixel aspect ratio as well. It's not really as important these days now that we use technology instead of film and analog TV. So in terms of the actual animation workflow, like what you would see in an animation studio, there's three basic components: pre-production, production, and production. Pre-production is putting together everything that you're going to need to create the animation. So that means writing the script, creating a storyboard, designing the characters, and recording the audio. One thing that's a little bit different with animation is that you tend to actually record an entire audio track before you ever do any of the animation, because the animation is made to match the dialogue or the audio cues in the recording track. And we can see here a little bit of the breakdown of the workflow. So we start with a script, then we add a storyboard and design the characters and create an audio recording. An animatic is basically like a simplified version of the animation where the drawings aren't done yet, but we just want to see what it looks like and sort of agree on the general approach. and then we add in, the rest of the character design and set up the audio, and then we go to the production side of things. In production, that's mainly doing the animation and then rendering out the final version. So depending on what style you're using, you can see there's different parts of the production workflow. So it kind of depends with 2D animation, with digital 2D animation, pretty much just going straight to the animation phase. You might do some layout posing if you're doing 3D animation. And then you're, putting it all together, rendering it, compositing it, adding any effects that you want. And then post-production is editing the footage together, adding the audio, and publishing. So putting it on YouTube or putting it on TikTok, or posting or submitting to film festivals, whatever it is that your animation is going. So next week we'll go over storyboarding a little bit more, and we'll actually make a little storyboard. And there's actually, if you want to, look at this, there's a template for creating a storyboard on the page for animation. And so you can open that up and you can, print this out if you want to. We're online, so I can't print it out for you guys. Usually we print it out in class and we work on it in class, but you can print this out if you want to, or you can fill it out on your computer. You could open it. Scribble on it if you want to. But a storyboard is basically what we use to plot out the, and so it's usually a very crude or rough sketch of where the characters are in the scene, and then what the dialogue is, so we can get a basic blocking of what happens in the animation before we commit or a few different types of software that we use for 2D animation. So we're obviously using After Effects. This is usually used for motion graphics and video compositing, but obviously it's also animation. Adobe Animate is another popular product that you can use to create animation. It's based on Flash, which was a old Adobe software that used to do a lot of animations as well as video games. You can also make animation in Photoshop. There's other animation programs like Harmony and OpenTunes that have similar effects. We're using After Effects mainly because it kind of has this very standard way of doing keyframes, and keyframing is a really important sort of concept to be able to do this type of digital actions. Some 3D animation software, things like Maya, Blender, Cinema 4D. These are all 3D modeling and animation programs that are useful. Blender is my favorite. That's the one that I use the most because it's open source, and I like the way it's set up. Cinema 4D is kind of more of the industry standard these days, whereas Maya kind of was before that. But Cinema 4D, if you're an animation major or you take more animation classes, that's what you probably. So a few things to keep in mind as we're creating our animations. We want to think about the relationship between frames. So what's happening in animation. We want to make sure that we're communicating what our story is. So even if it's very short and simple, we can still be clear about what we're trying to communicate. Thinking about timing. So timing is very important. It adds, life and naturalness to the animation. Thinking about workflow and a project plan is very important because it can take a lot of time to create an animation, which is why we're making something very short. And so planning things out and having a sense of how long things are really important in animation. Obviously important in any creative project, but in animation it kind of becomes especially important because of the amount of work that goes into it. And here's a few different animation resources for software, for different places where you can watch animation, like Film Board of Canada has a lot of really awesome animation work. And if you go to their website, you can see a lot of this gets published there. For whatever reason in Canada, they really fund a lot of cool animation projects. There's cool animation in the US as well, but there's a lot going on in Canada. So this is a website to check out. All right, so I'm gonna pause here. We're gonna go back over some of that stuff in demo format next week, but I'm gonna stop this part of the lecture